Have you ever thought about a problem so big, so complex, that it would take the fastest computer we have today billions of years to figure out? It sounds like science fiction, right? Well, it's not anymore. Today, we're going to pull back the curtain on quantum computing, a technology that's gearing up to solve the impossible.
Okay, so let's just dive right in. To really get why we even need quantum computers, we first have to talk about the limits of the computers we already have. And yeah, I'm talking about even the most powerful, room-sized supercomputers on the entire planet.
I mean, just try to wrap your head around that for a second. Not 1,000 years, not 1,000,000, but billions of years. That's older than the Earth itself. And these aren't just fun riddles. These are real problems that are holding back some of the biggest breakthroughs we can imagine. And we're not talking about some abstract math homework here. We're talking about really crucial stuff. Like, imagine trying to create a new life-saving drug. To do it perfectly, you'd need to simulate every single atom in a complex molecule. Or what about designing a brand new kind of battery from the ground up? Our current computers, as amazing as they are, just can't do it. They literally hit a wall.
So, if our current computers can't smash through that wall, what's the answer? Well, you stop trying to build a faster version of the same old thing. Instead, you build something completely new, a computer that works based on a completely different set of rules. Rules that are copied directly from how the universe itself actually works.
See, every computer you've ever touched speaks in a very simple language. Bits. A bit is either a 0 or it's a 1. It's on or it's off. And that's it. It's a black and white view of the world. But the funny thing is, nature, especially at the tiny, subatomic level, it doesn't really work in black and white. It's full of maybes, possibilities, and gray areas.
And that leads to this idea perfectly. We're not just making a small improvement here. We're building machines that speak nature's native language. They tap into the weird, the wonderful, and honestly the kind of mind-bending laws of quantum mechanics to handle information in a way that is just fundamentally new.
Which brings us to the absolute heart of this whole revolution. Meet the hero of our story, the quantum bit, or as everybody calls it, the qubit. This little guy is the building block that changes the entire game.
All right, so here is the key difference you need to know. A regular bit is like a light switch. It's either on or it's off, 1 or 0. Simple. But a qubit is more like a coin that you've just flipped in the air. While it's spinning, is it heads or tails? Well, it's kind of both, right? It exists in a state of all possibilities at once. And that one idea is the source of all of a quantum computer's power.
So that incredible ability to be a 0 and a 1 at the exact same time, that's a superpower. It's called superposition. And because one qubit can hold multiple values, a quantum computer can explore a huge number of solutions to a problem all at once. It's kind of like being able to walk down every single path in a maze at the same time, instead of trying them one by one. You'd find the exit instantly. But there's another superpower. And this one is so weird that Albert Einstein himself called it spooky action at a distance. It's called entanglement. This is where you can link two qubits together so they share the same fate. No matter how far apart they are, and I mean across a room or across the galaxy, if you measure one, you instantly know the state of the other. They are mysteriously connected, letting them work together in ways that are just impossible for normal bits. Okay, so we've got these qubits with these amazing powers of superposition and entanglement. That's cool physics, for sure. But so what? What does this actually mean for us in the real world? Well, let's see how these powers could literally change everything. We're not just talking about making faster iPhones here. This is about doing things that are completely new. Things like discovering those life-saving medicines by perfectly modeling how they work, or creating incredible new materials for super efficient batteries. It's about making AI way smarter, optimizing our entire financial system, and even creating communication networks that are physically impossible to hack. And to give you a sense of just how big a deal this is, get this. In a real-world demonstration, a quantum computer performed a calculation in about 200 seconds, a few minutes. The estimate for how long that same task would take the world's fastest supercomputer? 10,000 years. That's not just a little bit faster. That's a whole new reality of computation. Now, as amazing as all this is, let's take a breath. You're not going to be buying a quantum laptop next year. Building these things is, without a doubt, one of the biggest scientific and engineering challenges of our lifetime. Yeah, the hurdles are huge. For one, qubits are ridiculously fragile. The tiniest vibration, the smallest change in temperature, what scientists call noise, can knock them out of their quantum state. This is called decoherence. Then, because they're so fragile, you need really, really smart ways to check for errors without destroying the whole calculation. And finally, the biggest challenge of all is just scaling up, getting enough of these high-quality qubits to all work together perfectly.
But you know what? Make no mistake, the race is absolutely on. Labs and companies all over the world are pouring resources into this, and they're making incredible progress every year. We're living in a moment where we can literally watch something from science fiction become scientific fact.
So this leaves us with one last massive thought to chew on. Once we finally have this incredible power, this tool that can solve the impossible, what's the first thing we should ask it? How do we cure cancer? How do we reverse climate change? How do we finally unlock the secrets of the universe? The possibilities really are as limitless as the quantum world itself.